what? Then they go back and pick someone up. It's like Home Alone, and like without them.
The worst part is like Flynn was actually like, "Oh, we can just take him back," and they're like, "No, you can't take anyone back." So they made the boss come back, even though Flynn was trash. I mean,
So you convenience like a whole bunch of people.
Yeah.
When you didn't have.
I mean, their rules are.
I get it. Yeah. It's like a liability.
Yeah. Like Flynn crashed or something, then they'd be wrong.
Right. And it's still kind of frustrating. I mean, it is Flan, so. I don't even know what you guys thought.
Oh no! This is like left-hand turn. Yeah, he doesn't even look like when he gets to a left-hand turn. He tells us to look for him, and then we have to tell him if it's good or not.
What if he's not so? It's just hope. And then get out your book, and we're going to keep going through the notes from 4.2.
Every single time. And I went right after them every single time, and I have to move the seat all the way back, all the way, but I can't move my vibe between the seats.
She almost hit every single person.
Are you serious? Like,
We
in her car or like her?
went through the mall parking lot, and then she was like walking across it. I was like, oh my god.
Flynn hit a curb and was told he's not road ready and stayed.
The first time I ever did driver's training, I wasn't driving, but my friend was driving. And he had never driven like at all before. Like my guess, like I went out with my dad for like in a parking lot. My guess is probably a lot of people did that, but he never had. And so he turned. This is just like a regular like 25-mile road, but he turned right, street light right here. He turned right and just kept turning right, smacked right in the street light. Like forgot to, didn't know he was supposed to straighten it up or something.
He was like, you're making a show. When you got like one wrong on the first test.
Smart for being short.
And he said, you're actually pretty good. Okay, but keep in mind,
That is
he's like
true.
5'2". He's like 5'2".
He looks like Danny DeVito.
Oh, so
He
it's
looks
like
like Danny DeVito.
Dr. Tim. He would sing.
That's what Jenny has as her dog.
Are we okay on this?
He would sing a lot.
Am I going to keep this back on?
He would yell out the
Really want to like catch up on.
like we passed like the Pioneer football team.
All right, let's start looking at. Let's start looking at the rest of the notes here. We got through. So we didn't do average velocity or speed. I kind of talked about these, but I never like wrote them out for the notes. But velocity less than 0 means the particle is moving backwards. And backwards could mean left, or it could mean down, depending on if you're doing horizontal or vertical. If the velocity is negative, that means the particle is moving forwards. Forwards? Backwards sounds like normal, but forwards sounds weird. Is it? Okay. So that would be to the right or up. And remember on a graph, this means, what does velocity less than 0 mean if you're looking at a velocity graph? On a velocity graph, what's true if the velocity is less than 0? If this is my velocity graph and I said, where's the velocity less than 0? Below the axis, right? Lower half, yeah. So below axis. I'm not sure I asked that question, but this would be above x-axis. And this would be on the x-axis. And that means the particle is at rest because the velocity equals 0. average velocity is, they probably wrote this a little different, but in general, it's the end position minus the start position divided by time. So it's how much your position has changed divided by how much time you're talking. So if you went 20 miles in 2 hours, that's 20 miles divided by 2, so 10 miles per hour. That's not like a calculus, that's like if I asked you about average velocity in like honors physics or MSL, but like you haven't learned derivatives yet. And then speed is the absolute value of velocity. So speed is always positive. So if I'm going 40 miles an hour backwards, my speed is still 40 miles an hour. And then if I wanted to say it's negative, now I'm talking about velocity. So velocity has a direction attached to it. Speed does not. We talked about the speeding up, slowing down. So velocity, acceleration have the same sign. This particle is speeding up. And if they have different signs, the particle is slowing down. Hopefully, you've already looked at these notes and thought about it and processed them. I can just review. Hopefully that's the case. So, do I need to go through these or is this part of that? I mean, I can do it. These are different signs, right? So speeding up or slowing down. Slowing down, I'm just going to go down, down, up, up. Not fair enough for that part. Displacement is, so there's a big difference between distance and displacement. Displacement is your end position minus your start position. Distance, and I know they didn't put this here, but distance is how much you traveled. We don't really get into that. We can't really do that without integrals. So we'll get into that more second semester. The idea is if I start here and I go like 100 miles this way, and then I turn around and come back like 80 miles this way, my distance is 180 because I actually traveled 180 miles. But my displacement, like how far did I end up away from where I started? It was only 20, right? So like if I wanted to go talk to Trey, and I walk back there and it's 20 feet, and then I walk back, what's my distance? My distance traveled is 40 feet. But what's my displacement at the end of the day? I didn't really move, right? I just ended up where I started. Or some people will talk about, like, if you're swimming, this will piss you off. You swim 50 meters back and forth and back and forth and back and forth and back and forth. What's your displacement? You didn't do anything. You set it up where you started. Or on a track. You run around the track 400 times, what's your displacement? 0. So try to measure distance, otherwise you're going to feel pretty bad about yourself. Okay. Questions on like that page of notes right there? I should do that to like troll school. You didn't do anything. I don't know, right where you started. Alright. So these are, again, this is the problem in the notes, I know, but hopefully you've looked at them, tried to process them. This is the second time you're processing them, so that's going to go a lot better. The displacement is the end position minus the start position. I need to better use that. So during the first 2 minutes means the end position is where are we after that 2 minutes. The start position is where are we at the beginning. The end position is going to be whatever this is, the 2 to the third minus 4 times 2 squared plus 3 minus the the start position, well, what do I plug in for time to figure out the start position? 0, right? So it'd be 0 to the third minus 4 times 0 squared plus 3. And then, you figure that out, whatever it is. That'd be 8 minus 16. So negative 5 minus 3 would be negative 8. So I went 8 units backwards in the first 2 minutes. So if I were to kind of graph that, this is 0. I started at 3. I ended at negative 5. So doesn't that make sense that I went backwards 8 units? I went 8 in the negative direction. Okay? Trey didn't look happy about that. Plug it in here, you mean? 8, that's a cube. Yeah. Okay. Like your concepts make sense, right? You were just asking about that. Okay, that's cool. All right, average velocity during the first 2 minutes. So your average velocity is your end position minus your start position divided by time. It's really just slope. So your end position is negative 5 minus your start position is 3 over 2. So it would be negative 4. And what would the units be on that? Centimeters per minute. Good. So I know I'm dealing in centimeters and minutes, and then velocity has to be units per time. Alright. Am I going too fast? Okay. Alright. Find the velocity when t equals 4. So now we're doing it like algebraically. I think this is easier for most people than graphically. So the velocity function, well, that's position. So what do I do with that equation to find the velocity equation? Yeah. So how do I go from position to velocity? Take the derivative. If I want to go velocity to acceleration, I take the derivative again. So my velocity equation here would be v of t equals 3t squared minus 8t. Nope, I'm in the wrong. That's right. It's v of t equals 3t squared minus 8t. And then if I want the velocity at 4, I just plug in 4. So 3 times 4 squared minus 8 times 4. So that's 48 minus 32. So that would be 16 centimeters per minute. Okay for velocity? So acceleration is one more level down. So to go from velocity to acceleration, I take the derivative again. So I take the derivative of what I had after the first derivative. So this is 6t minus 8. So then acceleration at 4 is 6 times 4 minus 8, which is also 16. And what's the label on acceleration? If velocity is centimeters per minute, acceleration is centimeters per minute squared. If I went down another level after acceleration, you guys remember what that's called? Sure. What's the label on that? Centimeters per minute cubed. Yeah. You can like insult someone by calling them a third derivative. Speeding up or slowing down at t equals 4. And then why? Velocity positive or negative? Positive. Acceleration positive or negative? So if they're both the same, then we are speeding up.
such a nerd.
Okay. So this is the stuff. I guess I want you guys to tell me. This is the stuff we did yesterday. If you've taken notes on it, like you've got the answer in front of you. But I kind of want you to try. Do you want some time to look at this before I go through it and like see if you understand it, or should I just like start talking through it? Or does nobody care? I'll just go. Okay. So when is the particle moving to the right? So this is a velocity graph. So if we are above the axis, that tells us the velocity is positive and we're moving to the right. So wherever this graph is above the axis, so from 0 to 1, 0 should have a bracket actually. And then from, what the frick? Like, just make it go through 5, man. I don't know, 4.8 to 7. What the heck? So I'm supposed to, like, if I wanted to really find that, I'm supposed to find the slope between those two. And then, like, that's garbage. He is a third derivative. Why is 7 an open parenthesis and not a bracket? Is the velocity positive at 7? No, it's 0, which means what's true about the particle? It's at rest, it's not moving. I did put a bracket on 0 because if I said what's the velocity at 0, you would tell me 2. That's positive. When is the particle moving left? So that's important. Oh, justify your answer. Velocity is positive above x-axis. When is the particle moving left? So that's when we are below the axis. So that's from 1 to 4 point screw you, whatever that is. And that's because the velocity is negative or below the x-axis. Acceleration, where's that positive, negative, and 0? So we got to know how to look at a graph, how to answer questions about a graph that we can't see. So this is a velocity graph. I'm asking you about acceleration. So to go from velocity to acceleration, I need to go down one level. I need to take the derivative. I don't have an equation, I only have a graph. If I'm looking to take the derivative of a graph, what do I look for? Slope. So the derivative of a graph is the slope of that. So when the acceleration is positive, that means I want the slope of velocity, which is the derivative of velocity, which is acceleration, to be positive. So I want to know where this graph has a positive slope. So that's there. So from 2 to 6. Same idea for the negative. When is the particle's acceleration negative? Well, I want to go down a level from the graph that I can currently see. I asked about acceleration, but I can only see velocity. So the way I go down a level on the graph is to take the slope. So the slope is negative there and there. So it'll be from 0 to 2 and 6 to 7. You're saying this 0? That should be a bracket, shouldn't it? That's got a negative slope right there. What's the slope right here? It's not 0. Because 0 has to be like flat. That's undefined. I don't know what that is. It's a corner. We can't take the derivative. So I don't know what the derivative is there. I don't know what the derivative is there. If the acceleration is going to be 0, I need to see a horizontal tangent. Do I see any of those on here? Like a flat? So there's none. when does the particle have the greatest speed? What's the speed right here? 2. What's the speed right here? It's also 2. One thing you can do that helps like some people with speed, you just take anything that's, if you got a velocity graph, you take anything that's below the axis, and it gets absolute value, so it just flips up. So your speed graph would look like this. What? I still think I'm using it. Is that a stupid joke? Okay. So then, like, where's it the biggest is there? And there's a tie here. The greatest speed is at t equals 0 and at t equals 2. It's basically like what's farthest away from the x-axis. And then when is the particle speeding up? So remember, if you have a velocity, I think it's easier with a graph. Because you can look at like when's it going away? When is the graph? I shouldn't say it. When is the graph going away from the x-axis? So here and here, it is speeding. The particle is speeding up because the velocity graph is getting further away from velocity of 0. So it's speeding up from 1 to 2, and then 4.8 to 6. Because velocity, you can say it the way we describe it in a graph, velocity is getting further from 0 or from the x-axis. Or you can look at it like the positive negative way. So here your velocity is negative and so is your acceleration, so they have the same sign. Here your velocity is positive and so is your acceleration, so they have the same sign. So there's kind of 2 ways to look at that one. And then slowing down is just the opposite. So it'll be slowing down there and there because you're getting closer to the axis. Or you can say, well, velocity is positive there, but the slope is negative, so they're different sides. And the same idea here, they're different sides. The velocity is positive because we're above the axis, but the acceleration is negative because it's negative. The graph has a negative slope. So when is the particle slowing down is from 0 to 1. 0 should have a bracket because 0's fine. 0 to 1, and then 6 to 7. I'll just explain it differently this time. You can justify it a couple ways, so I'll just do one each way. So, oh yeah, I skipped one, didn't I? Thank you. Velocity and acceleration have different signs. Yeah, I did skip one, thank you. Because I also need to do, I just completely ignored that part of the graph. That was rude. So here your velocity is negative, but your acceleration is positive because the graph has a positive slope. Or you can say the graph is going towards the x-axis, so that would be from 2 to that stupid number. Questions on anything up there on the graph one? Can I erase this part, or am I still right now? It's in the notes too. I think it's stuck. Is that it? Now it's for practice. Alright. Good work. I imagine there'll be a lot of questions. I have no problem with that. Do what you can do. We'll come in on Tuesday, right? You triple derivative donuts on Friday. What?
Sad for you.
So do what you can do. Well, we'll come in on Monday and answer questions, and we might even do some more stuff with it. Depends how it goes.
We're gonna do tomorrow.
Oh, yeah. So no, I forgot that. Do what you can do. Come in tomorrow, and I'll answer questions, and then we'll see what we got from that. Yeah, I just skipped today in my head. I know.
Just for like the simple math stuff.
It'll probably be like the one where we have squared minus 8, you don't need to calculate for that. Right. Some of you might, but that's
3
your problem.
times 7 cubed minus.
So that's what you need to go. I mean, I'm not going to be like unreasonable.
Like when Noah's on your
It's
test.
completely possible to do, what was it, 5 and 6?
You weren't really supposed
No,
to.
he
No,
did.
that's not.
But he did.